In this video, we are going to talk about calcination principles. Now, we established that calcination is heating to cause deposition of volatile products, right? Which in this case, we have mostly water and carbon dioxide. Now, calcination is a thermal treatment process and is applied to ores and other solid material for the following reasons. So why do we apply calcination? So the first reason we are going to talk about is thermal deposition. Thermal deposition. Decomposition. Thermal decomposition. So we apply calcination. We apply calcination process to all bodies because of thermal decomposition. With thermal decomposition, this is whereby you are heating the ore without oxygen, and then what happens is that the inorganic products in the ore is being decomposed due to the heat. So in that case, you are removing inorganic components in the ore due to heat before further treatment. Now, the second one is phase transition. Phase transition. And with phase transition, you are changing the ore to a different composition due to the reaction between the thermal environment without oxygen. So you are trying to change it to a different composition for you to extract the mineral of interest economically using pyrometallurgy. And the third one is to remove volatile fraction such as carbon dioxide and water. So we have some ores which per their nature they are wet ores. So in that case, before we can treat them, we need to calcine the ore to remove the volatile fraction part of the ore. So these are the three important things. One, you see, materials is heated below the melting point in a rotary kiln. Yes, so their material or that ore body is heated below the melting point, right? So we don't want the material to melt, but we want to cause thermal decomposition. We want to have some phase transition and also to remove the volatile fraction of the ore body. And calcination is done in solid state. As you know that calcination is done in a solid state, the ore body must be solid before you can calcine, right? So calcination is done in a solid state. Let's note that. Yeah. Now let's go to some application of why do we need to calcine a material, or some application whereby calcination is needed. One, so application. Let's look at application of calcination. With application, one application is that to produce cement from calcium carbonate. So calcination is used to produce cement from calcium carbonate, and also to cause decomposition of hydrate minerals, as in calcination of bauxite to produce refractory grade of alumina. So that one too, we have some decomposition of that, and also to heat treat to effect phase transformation as in de-vitrification of glass material, cement from calcium carbonate, to cause some decomposition in refractory, to produce refractory grade alumina. And we have to cause decomposition of volatile matter contained in petroleum coke. So also it's applied in petroleum coke, and in that case we cause decomposition. And also we have another decomposition of hydrite from mineral. This is and also we have to heat treat effect phase transformation, as in vitrification of glass material, right? So we want to have some phase transformation. Phase transformation. Let's talk about some heat and material balance. Now look at this. One important thing is that calcination requires what? Thermal energy. Let's know that calcination requires what? Thermal what? Energy. Thermal energy. And also for calculation, we need several thermochemical values like heat of formation, specific heat, and heat content. So we in calculation, what we need for calcination, that we will be able to calculate the the thermochemical values like heat of formation. We have specific heat capacity, specific heat, and etc. So we are going to move on to the next step, which is what? Roasting. Let me see you